So I hope you had fun doing all those computations and finding out the MAD and the variance and the standard deviation. Just want to check your answers and see how you did. So first of all, you might just pause the video and look to see how our numbers compare. But the big thing here is, how do we get this set of numbers? This is the difference from the mean. So all of these numbers were literally found by just taking the number of cases in that state and subtracting the mean. Number of cases minus the mean, etc. Now notice, if the number of cases was greater than the mean, positive. If the number of cases was less than the mean, negative. And this sum of numbers will produce 0. So in terms of averages, it's not going to be helpful. So instead we get the absolute value. So just think about how far from the mean. Who cares if it's above or below? Just list it as a difference from the mean. Now, when you have a set of numbers, as you've seen with this idea of the mean or the average, rather than just have a set of numbers, we like to get a single statistic that represents that number, but it's not that's not the best way to describe it, as you know. The best way to describe it is if you took all of these differences, added them together, and then equally distributed them among the 7 states, how much would each one get? And if you add up all these numbers and divide by 7, I got 77.4. So for this set of data, these 7 states, the mean absolute deviation is 77.4. Much smaller than the MAD we got over here of 412.6. So the data over here is spread out. How far from the mean on average? 412.6. How far from the mean on average? Only 77.4. So in terms of comparisons, we would say this set of data is more clustered around the mean. It's not as spread out. It's more consistent around the mean of 134. This data is more spread out, and we have a number to be able to say that. Now the reason, one of the big reasons, is that 1709 in California, where over here we don't have such a big extreme. Yeah, we've got the 34, but we don't see the spread outness as much. And MAD, mean absolute deviation, is just a way to numerically, quantitatively figure out that, or to compare that to another data set. Now we also have another way to do that same thing called the variance and the standard deviation. The variance is found this way. Take those differences from the mean, square them, multiply by itself. Take 101.3, multiply it by itself. Take 114.3, multiply by itself, etc. Check your numbers. Now, the big idea here is you're just squaring, multiplying each of these by itself to get these numbers. Now, likewise, rather than have a collection of 7 numbers, we'll average them. We'll get the equal distribution. So total all of these up, add up these 7 numbers. Divide by 7 to equally distribute them, and the variance comes out to be 6819.6. Now over here, the variance was 258,000 because of that greater spread from the mean. This data set is not as spread out from the mean, so we get a lower variance. Again, it's just for comparison. Less spread out, more spread out. Now remember, this variance was based on the squares of those differences. So to produce what we call the standard deviation, we unsquare, to go back to the raw data, the number of cases of COVID-19. To unsquare, we square root. So the square root of 6819.6 is 82.6. So again, in terms of comparison, compare a standard deviation, a measure of spread outness of 82.6 compared to a 508.3. Much more clustered, consistent, clustered around the mean, much more spread out away from the mean. That's the value of standard deviation, variance, and or the MAD. Now it's not typical that one would report all of them. You would choose one in a study. You might choose one to report to make your case about how spread out a data set is compared to another. But in this case, I'm just showing you all 3. Now, as you work through some activities, you'll continue to practice this and interpret these numbers. I hope you see why, especially in educational settings, that this is useful information. Let's go back to work.